start. What is friction? Friction is a necessary evil. It is stated that manner. Okay?
Yes.
It is necessary, but you need friction. Without friction, we cannot sit even. Here I am sitting on the chair. There is force of friction between me and the chair. That's why I can sit here. The book is resting on the table. It is possible because there is friction between the book and the table. The camera I am sharing with you, the camera lying above the computer desk.
Yes.
There is friction between the camera and the computer desk. Then only it can be there. That's why people say that friction is a necessary evil. What is friction? Let us know. Whenever there are two surfaces in contact, there is always an opposing force opposing the relative motion of one object with respect to the other. Okay?
Yes.
So this object is resting on the ground, and if you want to move this object by using some external force, the frictional force will appear in a direction opposite to it. So external force acting towards right, frictional force acting towards left. It is opposing the motion, opposing force. And why this frictional force will arise? Will it arise if we take two surfaces which are very smooth, over smooth? If we perform the experiment by keeping one glass slab on another one and then try to move one from the other, your work will not be so easy. Okay? Why? Because there is friction between two glass plates. Friction is increased between two overpolished surfaces. Molecules of one surface enter the molecular range of molecules of another surface. Frictional force is increased. But this concept of friction, I'll be discussing end of the chapter. Right now, I tell you the force of friction, this FR, arise due to irregularity of their region of contact. You can see that this surface looking very smooth. Okay? The surface of contact appears to be very smooth, but if you see their point of contact, if you use a powerful optical instrument, then you will find irregularities are there. Sorry. You will find irregularities. Okay? So actually, two surfaces, if we consider this manner, which appear to be very smooth, but if we see it by using optical instrument which is very powerful, then it shows irregularities, and at the point of contact, there is interlocking of the two surfaces, interlocking of two irregular surfaces. This will cause friction between two surfaces. Due to interlocking, when you are applying external force this manner, due to interlocking, its motion will be opposed. Body A you are trying to move to the surface of body B, object B. Then, due to this interlocking, A will not move easily. You have to apply more force to move it. So friction at present due to interlocking of two irregular surfaces. But I just put forward a question before we move to the next topic, that the force of friction, which you have denoted by the letter FFR, comes under what category? Gravitational force, electromagnetic force, strong nuclear force, or weak nuclear force. These are four fundamental forces in nature. Weak force, just write weak force. Strong force, weak force. They are not strong force, weak force. They are not gravitational force. It will be electromagnetic force. Okay. This intermolecular attraction is due to electromagnetism only. So if a question arises, frictional force comes under what category? Your answer will be electromagnetic force. Force between the cord of the pulley and the object, which you bind with the help of the pulley cord, that is electromagnetic. I told you earlier, here also the force is. But nature of this force we will study properly in class 12. That's why authors remain silent. They will not say anything about this force in class 11 syllabus. But remember, this is electromagnetic by nature. Now, this frictional force we can divide into many categories. What are those categories? Force of friction, we can state this one as static friction, and number two, kinetic friction. What is static friction? Body stationary. Is there any force of friction? Let me write the definition, then I'll explain. This force of friction will arise during the stationary state of an object. Okay? But a question arises, it's just resting. How can I realize on the tabletop? On the tabletop, this brick is resting or a book is resting. How will I realize whether there is force of friction or not between the tabletop and the book or brick? to realize the force of friction, you have to apply the external force. If you have applied, then it will act tangential to the point of contact. Okay? But body may not move. Body remains stationary. That's why we say that the force of friction which appear during stationary state of an object is called static friction. Now a simple question arises. Suppose I have applied F external 3 Newton and force of friction will be what? So the body doesn't move. You have applied a 3 Newton force, body is not moving. What is the force of friction? For equilibrium, rightward force should be leftward force. If the body is not moving, this force will be 3 Newton only. If it moves, then it will differ. Right now, in case of static friction, this force will be 3 Newton. Suppose you have applied 4 Newton, then also it's not moving. Force of friction will be 4 Newton. 5 Newton, not moving. So force of friction, 5 Newton. So force of friction will appear just to balance the external force. This is the concept. Okay? Force of friction arises to balance the external force. And it will act tangential to the region of contact. So based on this, we can write the laws of static friction. Number one, it acts against the external force. It acts tangential to the surface of contact. Number three, its value independent of area of contact. Number four, its value independent of area of contact. Number four, force of static friction depends on the nature of two surfaces in contact. Number five, force of static friction, if you denote this one by Fs, it is proportional to normal reaction. Okay?
Yes.
What is normal reaction in this diagram? If the body has weight, say 5 kg, in this case, normal reaction, N is also 5 kg. And the force of static friction is proportional to this weight. N is 5 kg here. N is equal to weight most of the cases. But at the corner of tabletop, it will not be equal to the actual weight of the object. It will be a component of it. That I discussed in case of inclined plane. So here you just write the force of static friction is proportional to, no, that proportionality into convert to equality, that is going to be Fs is equal to mu s into n. This mu s equal to Fs by n. This is called coefficient of static friction. Fs is called coefficient of static friction. All right.
Yes.
So static friction you have understood a little bit. Let us do for limiting friction now. Just let me explain what is limiting friction first. Limiting friction. In that theoretical experiment, when an object resting on the surface of another object, as I have told you in the previous experiment, body is not moving. If we place an object here and pull it with some force, the object is not moving. It means what? There is force of friction, it's balancing the external force. You go on increasing the force. Then what will happen? Then at one instant, it starts moving. This object A starts moving on the surface of this object B. Now, suppose do this theoretical experiment. Till 5.9 Newton, it was not moving. Till 5.99 Newton, it is not moving. 5.999 Newton, not moving. Then just use a fraction of it. You increase fraction of it, 5 point, say, you have taken 5 nines. 5.99999, this way 5 nines you have taken, then it start moving. Then, as the object is moving, no longer it will be treated as static friction. But before that, that 5.999 when you were saying, this is approximately equal to 6 Newton, isn't it? But before that, when you applied 5.99, not moving. 5.999, not moving. Just 6 Newton applied, it started. So till this, the static frictional force was effective. We have increased 999. Suppose after 5 nines, after 9 nines, there it is coming. Then it is the body is, the object is moving. Object A is moving on the surface of object B. Then that is going to be the value of limiting friction. In case of limiting friction, it is the value of static friction only, but the maximum value of static friction up to which the object can be at rest. Okay, just beyond it, if you increase by fraction of fraction, then the object start moving. So let us define the limiting friction accordingly. It is the maximum value of static friction for which an object resting over the surface of another object resting over the surface of another object just balancing the external force or just start moving. So in the language of physics, this has no difference. Only thing you will remember that what is balancing till 5.89 are there, it is balancing. But after that, it start moving. So till that, it was balancing. Means when you apply additional force, body just start moving slowly without acceleration. So this is also case of equilibrium. You can say that in case of limiting friction, object is just balancing the external force or just start moving. Both are valid. It is the maximum value of static friction for which object resting over the surface of another object just balancing the external force or just start moving. All the laws of limiting friction same as that of static friction. Laws of limiting friction same as that of laws of static friction. There is no difference between these two. Okay. So we have learned what is limiting friction. Now, in case of limiting friction, I mean, or static friction, whatever you say, most of the time we'll be using limiting friction. But they are obeying those laws and even this mathematical relation, Fs equal to mu s into n. In case of static friction, just to go back to the experiment, we are applying external force, but the object is not moving. F external, and this is Fs. Or you can write Fr. Normally action upward in normally action, N is acting upward. It will balance the weight of the object. N is equal to mg. Now, the resultant of these two forces, N arise in the object, Fs also arise in the object. You take their resultant. The resultant Fr is the resultant of N and Fs. And the angle made by this resultant force with normal action is called angle of friction. So what is the angle of friction? And this is the reaction of actually total reaction. This is called why total reaction? Because Fs is reaction in it. N is the reaction in the same object. So total reaction resultant Fr is the resultant of Fs and N. So during static friction, we denote this one by the letter theta. During static friction, it is the angle between the total reaction and the normal reaction. Okay? So this angle theta between normal reaction and total reaction is called angle of friction. You can find its value easily in terms of coefficient of friction. How to? Let me do it. You can, as Fr is resultant of Fs and N, as Fr is the resultant of Fs and N, so Fs equal to what? A component with which it makes an angle 90 minus theta. So Fs will be Fr cos 90 minus theta or sin theta, and N is equal to Fr cos theta. Is that clear? Fs is Fr sin theta and N is Fr cos theta. Now just divide one by the other. 2 by 1. No, 1 by 2. So dividing 1 by 2, you get Fs by N equal to tan theta. But Fs by N we know very well. From the laws of friction, it is mu. So tan theta is equal to mu. All right. So you can say that this angle of friction will be in such a way that its tangent is the coefficient of friction. Therefore, tangent of angle of friction equals with the coefficient of friction. Okay. So angle of friction, tangent of angle of friction is equal to called coefficient of friction. Just one more thing we have to do here, then static friction will be over. That is conceptually, we have to do lots of sums. Angle of repose, let us define. What is angle of repose? You can say this one as angle of response also. It is responding something external. Angle of response. What? You just imagine an object is situated on an inclined plane. On this inclined plane, an object is resting. Mass m. So on this object, this block, what are the forces acting? That let us analyze first. Weight mg vertically downward. You know, this angle of theta is angle of inclination. This mg has a component mg sin theta this way, mg cos theta this way, and there is normal reaction. Okay. Normal reaction is perpendicular to the area of contact. Now, is there any force of friction? Yes, it is there because it has a tendency to slide that we have seen in Newtonian mechanics. With what acceleration it goes, that is g sin theta. But here, there exists friction between this object and the inclined plane. That friction always will oppose the motion. So that frictional force is Fs. Fs stands for static frictional force. mg sin theta balanced by Fs. But we don't want to see that it is getting balanced. What do you want to see? We want to see the object is disturbed little bit. How? How you can disturb the object? You can disturb the object by increasing the angle of inclination. Just this inclined plane, its angle of inclination will be increased. This is resting here, this block. Block is resting. It's not moving. Block is resting. So let theta be the angle of inclination. So just for equilibrium, what is happening? For equilibrium, Fs is mg sin theta, is balancing, and normal reaction mg cos theta. This is also being balanced. Now, if we go on increasing theta, now if theta is being increased gradually by increasing, theta is being increased gradually by increasing the component mg sin theta. Then what will happen? It was resting. That's true. But there will be an instant, if you make it almost vertical, then mg sin theta huge. We have this high value of mg sin theta, body may just start sliding. Okay? It may just start sliding because of mg sin theta. Now, if theta is being increased gradually by increasing the component, thereby increasing the component mg sin theta, the object has more tendency to slide down the incline. Okay? It is more tendency to slide down the incline. Suppose the value of theta for which the object just starts sliding, like previous case, or just balancing, then that value of theta is known as angle of repose. So let me define angle of repose. After this, what is angle of repose? Angle of repose is denoted by the letter lambda. So when theta equal to lambda, the object just starts sliding or just balancing. For theta equal to lambda, the object just starts sliding, or you can say just balancing the external force, just balancing the external force. Then this value of theta is said to be angle of repose. Lambda is known as angle of repose or angle of response. So put that value over there. Fs now is mg sin lambda, just balancing, same relation, just taking this thing. and n equal to this, you take number 4. So dividing 3 by 4, what do you get if you divide 3 by 4? That is becoming Fs by n. Mg get cancelled, tan lambda. Again, we meet this term. Fs by n equal to mu s. So tan lambda equal to mu s. This lambda equal to tan inverse mu s is known as angle of repose or angle of response. This is a theory for theory question. This is very important part. Sometimes they ask you to prove that angle of friction equal to the angle of repose. Here is the proof. Lambda tan inverse mu s, and we have seen that theta equal to tan inverse mu s. This is mu s only. So theta tan inverse mu s, and you got lambda equal to tan inverse mu s. So theta must be equal to lambda. An important conclusion or an important observation that theta equal to lambda. That is angle of friction equal to angle of repose. That's all about static friction at introductory level. Okay. Force of kinetic friction will arise when a surface moves on another surface. That's why it is kinetic. Kinetic friction is two parts. I mean, two different types of kinetic friction are there, not two parts. One is sliding friction, and the other one is rolling friction. Okay. Sliding friction, when a body slides over the surface of another body, that is called sliding friction. Rolling friction, when a body rolls over the surface of another body, then rolling friction. The force of rolling friction is much smaller than that of sliding friction. A body rolling over the surface of another body will experience less force. Sliding, huge force will experience. Okay. So yes, force of rolling friction that we'll discuss in rotational mechanics. Not now. You just remember this, the force of rolling friction, force of rolling friction is less than force of sliding friction. This much we'll just keep in our mind what is the definition and which one learns. But we will not work with it now. We'll work with it in rotational mechanics. What is the laws of kinetic friction? So kinetic friction will arise in which cases? Object is moving over the surface of another body by applying a force like this. Friction will arise there between two surfaces in contact. As it moves with some acceleration, say, then F K kinetic will act opposite direction. Similarly, object rolling on the surface of another object. This one rolls in this, when a body just sliding down the surface of another inclined plane or object, then also sliding friction comes into effect and it will act in a direction opposite to the direction of motion. Okay. So to write the equations of motion, we need to know laws of kinetic friction. Somebody has established the laws and that we are going to apply here. Experimentally, it is done many years back. Laws of sliding friction. First four laws, 1, 2, 3 and 4 remains the same. These four laws same as that of static friction. Okay. Fifth law we have to learn. The force of kinetic friction or force of sliding friction is independent of the velocity. Sorry. Force of kinetic friction directly proportional to the normal reaction, and Fk is independent of the velocity. These two are different. Rest is same. Let us work on number 5 first. That force of kinetic friction is proportional to N. This implies Fk equal to mu k into N. Okay. This mu k equal to Fk by N. This is called coefficient of kinetic friction. Okay, similar to previous one, it was Fk. This time it is Fk by N. So with the help of this, now we can write the equation of motion. I mean, acceleration of an object.
Sir, sixth lawটা একবার repeat করবেন please.
Which one?
Sixth lawটা.
Fk is independent of the velocity. Whatever the velocity of the object, Fk will remain the same. It is not going to change.
Okay.
Now, acceleration of an object on a, all these are verified experimentally and then stated in the form of laws. There is no direct proof of it. You can verify with examples, but you cannot prove it mathematically. Okay. Acceleration of an object on a horizontal surface. This surface is rough. Just you are pulling it this manner. Frictional force developed. F kinetic friction This is developed in opposite direction, Fk. In this part, mg. So what will be the equation of motion? If acceleration is given as a, the equation of motion will be like this: F external minus Fk equal to mass into acceleration, and Fk equal to mu k into n. N stands for normal reaction. This is nothing but mg in this case, because on a horizontal surface. So by putting all these values, you can get the acceleration. From one, acceleration would be what? F external minus mu k into mg by m. So this is the value of A, F external minus mu k into g. Acceleration of an object on a rough surface. If the object has no external force, suppose you have just left an object giving some initial velocity, no external force acting on it. Frictional force is there apart from that. You have given some initial velocity, but frictional force is there. Only you are not pulling with any external force. Then body will have retardation. It stops after some time. With this retardation, it will move. If external will not be there. Okay. On an inclined plane, on a rough inclined plane, weight mg acting vertically downward, you know. This way it is acting mg sin theta. This way mg cos theta. And when it is going down, force of friction acting opposite manner, Fk. Normal reaction opposite to mg cos theta. So Fq will be mu k into n. So what will be the equation of motion? If it is acceleration A, then equation of motion will be mg sin theta minus Fk ma. What do you get Fk? Fk equal to mu k into n. Mu k into mg cos theta. Just substitute there. So acceleration going to be g into sin theta minus mu k cos theta. Okay.
Yes.
This will be the acceleration of an object which is just left on inclined. But you could have asked me one question. Why is the guarantee that the body will move down the inclined plane? It may or may not move. How do we ensure that the body is moving? Let us make that part clear. So for downward motion, what condition is required? That acceleration should be greater than or equal to 0. It can move with uniform velocity also. So g into sin theta minus mu k cos theta greater than or equal to 0. So tan theta greater than or equal to mu k. Or tangent of angle of inclination at least should be equal to mu k, or maybe more than that. Clear?
Yes.
So this is the condition under which the body will move. Now I'll show you another case. When you are pulling an object up the inclined plane, then how much force is required and what will be the acceleration of the object? This object is resting here on the inclined plane. You want to move it up the inclined plane by using some external force, F external. Draw the forces same manner. Mg sin theta, mg cos theta. Then normal reaction is in upward direction. Okay. So how to write equation of motion here? Suppose due to action of this force, body moving with acceleration a. So equation of motion going to be F external equal to ma. But this is not enough because frictional force also there. No, that we did not draw. So there we'll put F Fr, frictional force, equal to ma. What is Fr here? Fr equal to mu k into n. And n is mg cos theta. So we get from here m into a equal to F external so acceleration given by this relation. And always keep your mind open to state that the body will have acceleration under what condition? If a greater than 0. So a greater than 0 means F external has to be greater than mg into sin theta plus mu k cos theta. Then only object moves up the incline. Clear?
Yes.
Now, after this, we have to learn just one more topic, then friction for school examination done. That is, which one is easier? That lawn roller you have seen, it is easy to pull it or to push it. Which one will be easier for you? That you can explain with the help of friction. So I'm just writing the question here. Which one is easier? To pull an object or to push. We can explain with the help of friction here. It's very easy. Suppose we have applied a force F1 here. F1. That mg acting vertically downward. Sorry, mg direction will be vertically downward. Mg acting vertically downward and normal reaction acting upward. The applied force which you have applied there will be having two components. If the angle it makes with x-axis with theta, this way component will be f1 cos theta and here frictional force. So let us write the equation of motion. Suppose the object is being moved with zero acceleration. Let us assume this first. Let the object is being moved without any acceleration. So f1 cos theta is being balanced by f1. No acceleration we have considered. And also this weight mg acting downward. Also f1 sin theta plus n also f1 sin theta plus n equal to mg. So n equal to mg minus f1 sin theta. Just put it there. This implies if fr is mu k into n, mg minus f1 sin theta so this implies f1 you take common and take it on the left hand side. So that value of f1 going to be this is the value of f1 when you are pulling it with this force required to pull it slowly, remember. Now when the object is being pushed forward, then what will happen? Let us compare. When it is being pushed, that force will go this way, F2 with the force. This way component will be, if this angle is theta, so component will be F2 cos theta it will be normal reaction and this force of friction will be opposing Fr. Again, we assume that the object moving with zero acceleration. So what will happen? Forces will balance. So F cos theta for equilibrium. You can assume that the body is moving slowly with zero acceleration. In both the cases, we have taken A0, writing the equation accordingly. What is the minimum force required? We'll compare on that. So F2 cos theta will be FR for equilibrium. Okay?
Yes.
But FR is what? That we have to find first. The normal action upward. This F2 cos theta, F2 sin theta and mg acting downward. So An equal to F2 sin theta plus mg. So Fr will be what? Mu k into n. So put it there. So this implies F2. This is also F2, of course. Okay, this is F2. Now take F2 other terms on the left side. So F2 going to be what? Look at these two expressions. Just let us compare these two expressions, F1 and F2. Both are in the same frame. Which one is larger in that case? This was for pushing. Denominator is less. Numerator has the same value as cos theta minus mu k sin theta less than. Therefore, just if you take reciprocal of it, this will be greater than 1 by mu k cos theta. Multiply both sides by mu k mg. This divided by clear. This force is for F2. F2 stands for what? F2 stands for pushing force. F1 is the pulling force. So to push the lawn roller to a rough surface, you have to apply greater amount of force. This I wanted to prove. It's done. Hope you have understood.
Yes, sir.